Hello and welcome. For this video, we're going to look at solving a problem that involves a quadratic where we know information about the roots. And we're going to show you two ways. Right? So here in this problem is a non-calculator question. We want to determine k such that this function has no real roots. And we're going to do it using the vertex form of a parabola, and we'll also do it using the discriminant. Right? And the discriminant is probably what more students are comfortable with or familiar with, right? So our discriminant is b squared minus 4ac, right? It is the part that is underneath the square root when I am working with the quadratic formula, right? And that is to be able to solve equations of the form ax squared plus bx plus c is equal to 0. And we know that if we have no real roots, that tells us that that discriminant must be less than 0. And so, therefore, in this situation, a is equal to -3, b is equal to 4, and c is equal to -k minus 1. So what does that mean for us? That means that b squared minus 4 times a times c must be negative. So 16, and if we come through, we multiply, we've got 16, right, minus 12 times k plus 1. That needs to be less than 0. So that means that 16 needs to be less than 12 times k plus 1, which means that if we solve this, divide by 12, 16 over 12 needs to be less than the quantity k plus 1. So therefore, k needs to be greater than 16 over 12, which is 4/3, minus 1. So k needs to be greater than 1/3. So that's solving this with using the discriminant. So if k is greater than 1/3, we know that this function right here will have no real roots. Right? If it was calculator active, we could certainly come in and use something like Desmos to graph our function. And what's nice about Desmos is it will allow us to create a slider. And so we've got our function f of x is equal to, what do we have here? What is it? -3x squared plus 4x minus k. So -3x squared plus 4x minus k minus 1, and we can add this slider for k. So we'll notice here, all right, if I make this just a touch smaller so that we can see more things. All right, here we are. Okay, so we can see most of our page. Right, so we can see here that with our slider, and if we look at our equation, -+4x minus k minus 1, we've got that correct, that at k equals 1, we don't have any real roots, right? And if we look at k equals 0.3 or less than 0.3, we seem to have real roots, right? And if I kind of come over at 0.4, I seem to have no real roots, right? I can zoom in. And so it does seem that somewhere between zero point 0.3 and 0.4, I go from having 2 real roots to having no real roots. So I could certainly come in and say, oh, okay, well, it does seem like, right, it does seem like that k greater than 1/3 is valid for us. Now, if we wanted to use the vertex form of a parabola, which some people do, right, we could use the idea and say, hey, I know this parabola opens downwards, and so I would know that the y value of that parabola needs to be less than 0, right? The vertex value needs to be negative if I'm going to have no real roots. So, what's going to be the vertex of our parabola? The vertex, right, or the vertex form of our parabola, we know we can do by completing the square, but we can also do by using this idea from the quadratic formula that our vertex is going to be at x equals opposite b over 2a. So this vertex is going to be at x equals opposite 4 over 2 times negative 3, so that's going to be at x equals, let's set that up, right? So that's going to be for us at x equals 2 over 3. Then f of 2 over 3 is going to be negative 3 times 2 over 3 squared plus 4 times 2 over 3 minus k minus 1. If I do that mathematics, that's negative 3 times 4 over 9 plus 8 over 3, right, minus k minus 1. And if I continue with this, this is negative 4 over 3 plus 8 over 3 minus k minus 1, and that needs to be less than 0. Well, that means that negative k plus 1/3 needs to be less than 0, which means that k must be greater than 1/3. So it doesn't matter the approach that we use, we can get to that same answer, and we can certainly use something like Desmos to help us check if our work is valid. Now, of course, if this was on a non-calculator assessment, you really can't check it because you have no calculator. But what's nice is if it was a calculator-based assessment, you could use a calculator and check your work. So there we are. Thank you very much for your time.